We've gone a long way. We've come from the galaxy web to the nodes and filaments to the superclusters and clusters and groups and individual galaxies that make up those nodes and filaments. Now it's time that we take a look at the individual galaxies themselves. What are galaxies? What is a galaxy? Fundamentally, a galaxy is a gravitationally bound structure made up of dark matter and regular matter. Now let's get a little more into it. When you look at a galaxy, what you're seeing is a halo of dark matter. Inside that halo is a bunch of gas of hydrogen and helium. And then there are stars, there are stellar remnants, that is, the leftovers of stars. There's dust clouds, and then, very interesting for us, there are planets orbiting around some of these stars. Now all of these things that I mentioned are orbiting around the center of the galaxy. And that's what makes it a galaxy. Galaxies are differentiated into four main types. And here we'll look at this diagram to get a better idea. So you see on the far left, there are the ellipticals. Right to the right of the ellipticals, there are a couple of things labeled lenticular. And then there are a bunch of spirals. And then to the far right are the irregulars. So let's work our way through this. From E0 to E7 are the elliptical galaxies. These galaxies start off with a very spherical galaxy with E0, and then by E7 we have almost like a capsule-shaped galaxy, a very squashed ellipsis. Now even E0 isn't a perfect sphere, these are all ellipsoidal, squashed circles. What are the characteristics of these? These are the biggest galaxies that exist. Now, there are plenty of smaller elliptical galaxies, but the biggest galaxies are elliptical. These galaxies are made up primarily of very old stars. They have very little dust. It's very rare that you're going to find a new star there, and if you find a new star, it's usually not a new star, but rather some chicanery that's going on in between two different stars that make it seem like there's a new star. They have very little dust and gas, very little new star formation, mostly very old stars, and they're some of the biggest and some of the smallest things in the universe. Moving a little bit to the right, we see the lenticular galaxies. Now these aren't spherical and they're not elliptical. These are disks. We're looking at them in this image face on, but if we look at them head on, like in this image, you'll see that they're flat. These have a bit of a bulge, and they could have a little bit of a halo, but like elliptical, they have very little dust, they have very little gas, and they have no new stars. However, their disc-like shape is like the spirals, which we're going to get to next. So here are the spirals. Now you see the spirals going up and the spirals going down, and then the intermediate spirals. The top spirals are called regular spirals or normal spirals. The bottom spirals are called barred spirals, and the intermediate spirals are just in between these two. The main thing that differentiates regular spirals with barred spirals is whether or not they have a bar at the center. If you look at the edge of the bar in the barred spirals, that's where the spiral arms of the galaxy are coming off. But if you look at the normal spirals, there is no bar. The spiral arms are just coming off of the center. Now, these galaxies are made up of a number of different parts. In the center, you have a bulge, and you have a halo around that bulge. And over there, it looks very much like an elliptical galaxy or a lenticular galaxy, in that not much star formation is going on there, and there's relatively little gas and dust. But in the spiral arms of these galaxies, that's where all the difference is happening. Over there, there's a lot of gas, there's a lot of dust, and there's a lot of active new star formation. And that brings us to the last type of galaxies, and those are the irregulars. And irregulars are not shaped like anything. They're a bit odd. They sometimes look like they might have been stripped from a spiral galaxy, like they're a part of a spiral galaxy. But regardless, these irregulars have gas, they have dust, they have active star formation, and they're often very small. I should mention about the spirals, I called one a normal spiral and one a barred spiral, but normal just is referring to the spiral type, not referring to saying that that's the normal type of galaxy. In fact, only 1/3 of spirals are normal spirals, and 2/3 are barred spirals. We have an idea of what galaxies are now and what kind of types they come in. Now let's get a sense of the relative scale of galaxies. So the best thing to do is talk about the smallest galaxy and the largest galaxy. The smallest galaxy that's known has 1,000 stars and is about 2/3 the length of a parsec across. The largest known galaxy is a little over 1 million parsecs across, so that's a scale of about 1.5 million. However, most galaxies are between 1,000 and 100,000 parsecs. So most galaxies are ranging by a factor of 100, but the actual scale of galaxies is about 1.5 million insofar as we've been able to see. So now we have a basic sense of what galaxies are, we know the various types that they come in. Now it's time to move on to the main thing that makes up galaxies that we could see anyway, and that are stars. But stars come in clusters, or at least often enough. What are star clusters? Till next time.